Good afternoon. Today we'll be calculating the probability of certain events happening in card games. May the 4th be with you. Before we get into any examples, let's do a little bit of review of what probability means. Probability is the event that something might happen, and you can calculate it with the ratio of the number of ways that that event could occur divided by the total number of outcomes that are possible. So, our examples today use a deck of cards, and there are 52 different cards in the deck. Those are broken up into 4 different suits. There are clubs, spades, hearts, and diamonds, and 13 different ranks, aces, twos, threes, and so forth, all the way up to kings. And the first question is simply, how many combinations of 5 spades are available? And so if I looked at the 13 cards here and I just wanted to pick 5 of them, I don't care what order they're in, because once they're in my hand, I shuffle them around anyways. How many different ways could I do that? That's a simple combinations problem. And so out of 13 possible spades, I'm going to choose 5 of them. To make that calculation, you have to find it in the math menu. And so you would type the 13 first, and then hit math and go over to probability and choose the third option down, NCR, and 5. So 13 NCR 5 is 1,287. So let's use that information now to answer a probability question. This question says, what's the probability of getting a flush? A flush is when all 5 cards are the exact same suit. Now, when we calculate a probability question, you need a fraction. And so the top part of the fraction is the number of ways of getting what you want. And the bottom part of the fraction is the total number of ways of making something happen. And so in this particular choice, we've got 13 different spades we could choose from, and we want 5 of those, and so we found that earlier. That was 13 choose 5, right? That's how many different ways there are of getting all 5 cards the same suit. And then the denominator here is going to be the total number of ways there are of picking 5 cards. And so there are 52 total cards, and we need to pick 5 of them. And so that would be another combinations question, because I don't care what order they're in. I just want to know how many different ways there are of making that happen. So let's calculate each of these. We found the top already. That was 1,287. The bottom, 52 choose 5, is a number we'll use quite a bit in these calculations. 52 choose 5 is 2,598,960. And so you could sometimes leave your answers as fractions like this, but I have no idea what this is equivalent to. So let me divide those a moment. 1,287 divided by 2,598,960. That is, tiny. It's 4.9 times 10 to the negative 4th. That's equivalent to 0.000495, or way, way, way less than 1%. It's very unlikely at all. Now, before we go any further, there's another principle that we might need to answer some more challenging questions, and that's the fundamental counting principle. That says, in short, if there are m different ways of doing something and n different ways of doing something else, and you need to know how many different ways there are to do both, you multiply those ideas together. Now, have a little bit of a fix we need to do in that last problem, because in that last problem, there were 1,287 ways that we could choose 5 spades. But a flush doesn't have to be spades. It could be clubs or spades or hearts or diamonds. There are 4 different suits, and I need to choose one of them to do. And so the numerator of this is actually not just 13 choose 5, but I have to multiply that by 4 choose 1. The bottom's still the same, because there are 52 cards and I'm choosing 5 of them. And so if we calculate these on top, this is still 1,287, but I need to multiply that by 4. And so that's 5,148. The bottom is still the 2 million number. And this is still a ridiculously small probability. In fact, it's still less than 1%. But I wanted to be a little bit more accurate than we were. Let's look at a little bit more complicated question. How many different combinations of pairs are available? And so to answer this question, first of all, what is a pair? A pair is when you've got two that are the same rank. So say 2 5s or 2 9s. And so to answer this question, there are two different things that we need to choose. We have to choose which rank to make our pair in, and we've got 13 different choices there. And then we also need to figure out, once we've chosen a particular rank, how many different ways are there of getting a pair of those. And so the first idea is simply, out of the 13 ranks, I have to choose one of them. Once I've chosen, say, the 3s, now there are 4 3s, and I need to choose 2 of them. And so that's 4, choose 2. 13, choose 1 is simply 13. 4, choose 2, you could type into your calculator, or if you'd like, you could reference Pascal's triangle for that. Remember, that's the 4th row down, and then this would be how many ways there are of choosing none. This is how many ways there are of choosing 1. There are 6 different ways that we could choose 2. So 13 then times 6 would be 78. So there are 78 different ways that we could choose a pair. Now, how many different ways are there of choosing a pair and then 3 other cards? And so that will be the 78 ways of choosing a pair. And then we also need to think about, what about those 3 other cards? Those 3 other cards can't be the rank that we have already chosen, because otherwise we no longer have a pair, but we'd have what's called a 3 of a kind or a 4 of a kind. And so they have to be part of the other cards. So we've got 52 total. Once we've chosen a rank of 3, there are 48 other cards possible. And so what we would do is take the 78 ways of making a pair, and we would multiply it by 48, choose 3. And so 48, choose 3 is way down in Pascal's triangle. It's the 48th row down, and I don't have a triangle that big, so I have to type it into my calculator. 48, choose 3 is 17,296. And so if I multiply 78 by 17,296, I get 1,349,088 different ways of having a pair and 3 other cards. So let's combine those ideas together then in a question. What's the probability of getting a pair if you're dealt 5 cards? So to calculate probability, you need the total number of ways of getting something you want divided by the total number of ways of getting something. And so the total number of ways of picking 5 cards, we found that earlier. That was 52, choose 5. The number of ways of getting a pair was what we had just found. That was out of 13 ranks, choosing 1. Multiplying that by 4, choose 2 for the number of ways we can pick 2 cards out of 4 once we've chosen that. And then we need to multiply that by 48 remaining cards, and we have to choose 3 of them. And so let me make this just a bit bigger so you can see that. And so this calculation should give us our probabilities. Let's find those numbers then. Our numerator from before was 1,349,088. Our denominator from before was 2,598,960. Excuse me, 960. And we can see that this is close to 50%. Let me type that in a moment. So I get 0.519, or yeah, about 51% of the time. All right, here is a related question, not quite the same. This says, what's the probability of getting dealt a full house, which is a pair of cards and a three of a kind? So let's see if we can work that out. The bottom is going to be out of 5 cards again, and so we can write that one in already. That is 2, 5, 9, 8, 9, 6, 0. Total ways of choosing 5 cards out of 52. The top is going to be the number of ways of getting a pair, as well as choosing a three of a kind. And so the ways of choosing a pair was there are 13 ranks that we could choose from, and we're choosing one of them. And there are 4 cards within that rank, and we're choosing 2 of them. And so there's how to get a pair. And then the three of a kind, there are, again, well, now there are 12 different ranks possible. And so out of the 12, we're going to choose one of them. And to get a three of a kind, there are 4 cards in each rank, and we have to pick 3 of them. And so for choosing 3. And so this should do it. If we calculate each of these numbers, 13 choose 1 is 13. 4 choose 2 was the 6 that we had found earlier. 12 choosing 1 is simply 12. And 4 choosing 3, if I remember right from Pascal's triangle, was 4. And so if we calculate all this, 13 times 6 times 12 times 4 is 37,044. And so here is the odds written as a fraction. And if you want to have that as a percentage, we'll have to actually divide it out. I'm sure it's very small. It's 0.00144, so less than 1%. So let me leave you with a question for you to try. This question says, what's the probability of getting a pair of jacks when you're playing euchre? So a little bit about the game of euchre if you're not familiar with it. It uses a smaller deck of cards, so still 4 suits, but only 9s, 10s, jacks, queens, kings, and aces. So there's only 24 cards total. And you're usually dealt 5 cards at a time, similar to poker and the other questions we've calculated today. So why don't you hit pause, see if you can calculate this a moment, and then hit play and resume and check your work. So when I calculated this earlier, I tried to find the ways of getting a pair of jacks and then 3 other cards. And so to get a pair of jacks, there are 4 jacks available, and you're choosing 2 of them. If you thought you needed to multiply by 6, choose 1. That would be if you just wanted a pair total, but I'm specific about jacks because in euchre, jacks are extra special. And so out of the 4 jacks, I'm choosing 2 of them. Then out of the 20 remaining cards, I don't care what they are, I'm just going to choose 3 of them. And then the denominator is out of 24 total cards, I'm choosing 5 of them. And so when I calculated some of those numbers, 4 choose 2 was 6, 20 choose 3 was 1,140, and 24 choose 5 was 42,504. And that calculation works out to be about 16% of the time. Hope you did good. Hope you have a wonderful rest of May 4th day, and may the 4th be with you.